To verify our next identity, again, we're looking for the most complicated side. And to me, that looks like the left. So I have cosine squared of x minus sine squared of x. Now, looking at this, what I want to get it to, I want to get it so it is all in terms of sine squared of x, which means I need to get rid of my cosine squared of x. Okay, so looking back, I can see that my cosine squared of x is equal to 1 minus sine squared of x. So wherever I see my cosine squared, I'm going to replace it with 1 minus sine squared of x, and I still have minus a sine squared of x. So I still have my 1, and then minus 1 and minus 1 makes minus 2. These are like terms. Sine squared of x. Okay, so 1 minus 2 sine squared of x, we verified because we have our starting point, we used equivalent algebraic expressions, and we have our finishing point. Okay, our next one. So here I have tan theta plus cotangent of theta equals secant theta times cosecant of theta. So this one is kind of strange to figure out which one side is more difficult. Okay, so we have two functions on the left side, we have two functions on the right side. I will tell you, in general, addition and subtraction are more complicated than multiplication and division. Okay, because with multiplication and division, a lot of times we can divide out. With addition and subtraction, we have to find common denominators. We have to do things that are more complicated. Okay, so I am going to start with this left side. I have tangent of theta plus cotangent of theta equals. Okay, so the first thing that I'm going to do is I'm going to because I don't see anything that I can do right away, is I'm going to write this in terms of sine and cosine. So I have sine theta over cosine theta plus cosine theta over sine theta. Okay, I don't think this is super intuitive. I think this is something that the more of these you do, the better you get at them and you see the same tricks. So my advice is definitely to keep up with it as much as you can. When I have two fractions like this, my trick is to find a common denominator. So I am going to write a common denominator of cosine theta, sine theta. So in order for this to be cosine theta, sine theta, I need to multiply sine theta by what's missing in this denominator. So I'm missing a sine theta, so this becomes sine squared theta. Over here, I'm missing, right, to get cosine theta, sine theta here, I need to multiply the top and the bottom both by cosine theta. So this becomes plus cosine squared theta. If that wasn't clear to you, please come for extra help. This has to do with adding fractions. Okay, we can go over it a bit. So now I notice that sine squared theta plus cosine squared theta, whenever I have something squared, I'm thinking I'm going to use one of my Pythagorean theorems. And I remember that sine squared theta plus cosine squared theta is 1. So I get 1 over cosine theta sine theta. And I see that I can rewrite this as 1 over cosine theta times 1 over sine theta. That's still equivalent. And then I see that 1 over cosine theta is equal to secant theta. And 1 over sine theta is equal to cosecant theta. Okay, so now I am where I want to be. So I have proved my identity. Okay, real quick, we're still checking for our formatting. See how nice and clean this looks? All your equal signs lined up. Okay, space under one side. For our next problem, I can see that my left side is much more complicated. So I am writing that down first. Then I see that I have cosine times secant. I remember that those are reciprocals, so now I have 1 over cotangent of theta. And I remember that 1 over cotangent of theta, I'm using another reciprocal property, is equal to the tangent of theta. Okay, so now I'm back where I started, or back where I want to be, so I can put my check mark and my identity is proven. Okay, letter H. I noticed that my left side, I didn't do a very good job of switching up the sides. You really can have your left or your right be more complicated. But my left side is more complicated. Okay, I shouldn't have this one. I'm sorry. And I'm not going to have room, so I'm going to write this a little bit below. So, looking back at my Pythagorean theorems, okay, I can see that tan squared of x plus 1 is equal to secant squared of x. But we can flip the order, and 1 plus tan squared of theta is going to be equal to secant squared of theta. So we still have our cosine squared of theta. That's coming from right here. And then we're going to replace our tan squared of theta plus 1 by secant squared of theta. Okay, and then cosine and secant are reciprocals since they're both squared. We can see that this is equal to 1, which is where we wanted the right-hand side to be. Okay, our next one. So for this one, we actually have one where the right-hand side looks more complicated. So I am going to start with my right-hand side. So I can see that eventually I want to get a cosine in here. Okay, and I remember that sine squared and cosine squared are related. So I can replace 1 minus sine squared of t by cosine squared of t. Okay, if you look at those manipulated Pythagorean identities, okay, over sine of t. And then I know I want to have a cosine t out front. So I'm going to take one of those cosines and pull it out front. And I'm left with cosine t over sine t. So my cosine t is staying the same. And then by definition, cosine over sine is equal to the cotangent of t. Okay, so again, exactly what I want on my other side. So my identity is proven. Okay, again, formatting. Whatever I started with, nice equal bars lined up, all of my steps nice and clean, and a check mark to show that I finished. So our next one, we have secant squared of t over tan t, and I'm trying to get it to look like secant t cosecant of t. So what I'm going to do, I am going to start with my left side because it does look a little more complicated to me. And I'm going to see right away that I want to get a secant t out there. So I'm going to rewrite this as secant of t times secant of t times 1 over tangent of t. Okay, so I still want that secant of t there. So I'm going to keep that secant of t there, but I'm going to write the rest in terms of sine and cosine. So this is going to become 1 over cosine of t. And then 1 over my tangent t. Tangent t is sine over cosine. So the reciprocal is going to be cosine t over sine of t. So my cosine t's are going to divide out, and I'm left with secant of t times 1 over sine of t. So I still have my secant t, and 1 over sine of t is going to simplify to the cosecant of t, which is what I wanted. Okay, these are very complicated. There are more than one way to find many of them. Okay, you want to work on making them sort of as efficient as you can. You want to make your identities happen in as few steps as possible. And the best way to do this is really lots and lots of practice. We'll be working on this all week. Okay, I do think that there are some strategies that you want to be keeping in mind as you do these. Okay, first, rewriting in terms of sine and cosine is always helpful. Looking to simplify negative arguments using the even and odd identities. Using algebra properties, so splitting fractions, combining fractions, factoring. We haven't done this yet, but we're going to use conjugates. Okay, you want to look for squared trig functions to use the Pythagorean theorems in their alternate forms, and you want to try working both sides until you find expressions that are equal. So we haven't gotten to that yet either, but we will over the next few days. This is generally a pretty difficult section for a lot of students. Practice, practice, practice is what is going to help you. Please come for extra help if you need it.